Hello everybody, Miss Collin here, and I'm going to talk a little bit about a combination of 11.7 through 11.10, specifying on z-scores and standard deviation. So this is page 56, 57, and I'm going to dive in a little bit to the rest of the packet, 58 through 60. Okay, so we are talking about z-scores here, and z-scores are a common unit or a standard deviation to show the distance from an actual data point to the mean. All right, so we'll talk a little bit more about the formula of a z-score on the next page, but it's important to know that a z-score is not too far from a standard deviation. Okay, if you get a z-score of 1, this tells you that you are 1 standard deviation, and I'm going to do SD as an abbreviation, above the mean. Okay, so what does that mean? Well, that means you fall in this area here. You're 1 standard deviation above the mean if you get a z-score of 1. If you have a z-score of -1, this means that you are 1 standard deviation below the mean. Okay, you are in this range of data. You are right below the mean. Okay. If you get a standard deviation score of 2, this means you are 2 standard deviations above the mean. Okay, and why do we not just use standard deviation? Why do we not just use, well, why don't you just say you're 10 above the mean, Miss Collin? Because the standard deviation depends on the problem. So this tells me that you're even a little bit further from the mean. You were up here compared to everybody else. Okay. And lastly, what if you're -1.5? That doesn't fall in here, Ms. Collin. Well, it just means you're a little bit further than just 1. You're about here in the data. Okay, you're between -1 and -2, and you're -1.5 standard deviations below the mean. Okay, and I decided to type that whole thing out. Okay, so it makes a little bit more sense when you have some context with your z-scores here. So let's come down here, and here's an example. Okay, if we have a normal distribution of scores that has a standard deviation of 10 and a mean of 50, okay, they want us to draw the bell curve. We should know from 1110 how to draw a bell curve. We're going to kind of draw a line here, and then we're just going to kind of draw a curve to the best of our ability. All right, and it has a mean of 50, so I'm going to go right in the middle here. It's normally distributed with a mean of 50, and I know that if it has a standard deviation of 10, I'm just going to add for my first standard deviation, it will be at 60. For my second standard deviation, it will be at 70. For my third standard deviation, that will be at 80. All right, at my negative first standard deviation, that will be at 40. My negative second standard deviation will be at 30, okay? And my negative third standard deviation will be at 20, okay? So that's how we're going to break that up. So here's some questions in a way about it. This is saying, okay, so if you have a score that is 20 points above the mean, that means your z equals 2. Why? Well, because if it's 20 points above the mean, I'm right here at 70, and that is here's my first standard deviation, here's my second standard deviation, third standard deviation, negative first standard deviation, negative second, negative third, right? So I'm at my second standard deviation here. That's a z-score of 2, okay? Reason is that 20 points above the mean is 2 standard deviations away. Okay, so that's that. So now they're asking me, okay, well, what is your z-score? If you have a score that is 10 points below the mean, if I'm 10 points below the mean, I'm right here at 40, right? So I have a z-score of -1. Why? Well, my standard deviation equals 10, so 1 standard deviation below is 40 at -1 standard deviation. Okay. So we can keep kind of following this pattern. What if you have a score that is 15 above points above the mean? Well, here's 60, here's 65. That would be at 1.5 standard deviation. So my z would be 1.5. Okay, why? Well, my standard deviation is 10. So one standard um 1.5 would be 1.5, or land halfway between 60 and 70. Okay. All right, what if you're 30 points below the standard deviation, or below the mean? My bad. Below the mean. Well, my mean's at 50. If I'm 30, I'm all the way here at 20, and that's a standard deviation of that's a z-score of -3. Okay, why? Well, 10 times 3 is 30. Okay, and that's below the mean of 50. Okay, obviously your reasons here can kind of differ. There's a lot of different ways to kind of reason this, but I'm just giving you the general idea of what a z-score is. Okay, so that's only one way we're going to talk about the z-score. If you turn to the next page, we're going to talk about the z-scores formula and how we can actually find the z-score and what it kind of tells us. So I think this example here is a great example. And here's the formula, but I also want to be careful with this formula because X bar really, with our normal distribution, instead of, sample mean, we're really using mu, okay, which is our population mean. So it's really just our mean in general. You can use it for either, obviously, but a lot of the times we're going to be talking about mu. So I want that to kind of be in the back of your head as well. Okay, what does X represent here? This represents the score that you get. Okay. Obviously, X bar or mu always represents our mean. And then this obviously represents our standard deviation. Okay. So an example here is Lewis earned 80 on earned a score, it doesn't say that, but right, that's his score of 80 on his biology midterm. And a 71 on his history midterm. Okay. In the biology class, the mean score was 75 with a standard deviation of 4. So I'm just kind of highlighting everything having to do with biology in red and everything to do with history in green. So in the history class, the mean score was 73 and a standard deviation of 3. So here I have a nice little setup for you guys. Okay, set up your biology and set up your history information. Well, for biology, I got a score, or Lewis got a score of 80, right? His mean score, the mean score of the class, was a 75, and the standard deviation here was 4. Whereas in history, Lewis got a score of 71, the mean score was 73, and the standard deviation was 3. Now, before we even get into the z-score, we can already kind of tell, okay, well, Lewis did lower than the mean here, and he scored higher than the mean here. Okay, but our z-score tells us by how much, in what percentile does he kind of fall into. Okay, so let's come here and we're going to use our formula. Z equals, we're going to do 80 minus 75 divided by 4. Once again, this is just from the formula above. 80 is our score, our mean was 75, and our standard deviation is 4. Okay, so we have 5 over 4, which gives us 1.25 z-score. Okay, for history. Okay, so for biology, the z-score, we are going to take 71 minus 73, all divided by 3, okay, which is -2 over 3, okay, which is negative 6.7 about. Okay. So this tells us some information once we're given the z-score. This tells me that I am 1.25, standard deviations above the mean here, while I am just a little bit below the mean here, not too far. Okay. Did he do better than half the class in biology? Yes. Right? Half the class, that cuts off at the mean, has a score of 75, right? But did he in history? No. Okay, he was just below the mean. He was just below half the class. Okay, which class did he do better in? Well, he obviously did better in biology. He was 1.25 standard deviations above the mean in biology, while in history he was 0.67 below the mean. Okay. All right. Okay, for the next part of the video here, this problem, you will need a z-score table. Okay, so if you looked up in the z-score table, you would go to 0.15, and you would find a z-score of 1.04. I'm not pretty sure we're not really going to be using z-score tables, so I'm not going to talk too much about them, but the z-score would be 1.04. And we can solve this then by using simple operations. Okay, multiplying by 100, that's 104. So 104 plus 500, because we're going to add that 500 over, we get 604 would have to be our minimum score. Okay, I'm going to have you skip this part. And like I said, we'll practice more of those if we have anything with the z-table, but I do not believe we do on our test. Okay, so coming up to the next one here, you guys should be able to do the rest of these problems here. So I want you guys to finish these out. You're just finding the z-score. So you're using the formula, your score. Okay, so here the score is 45 minus your mean divided by your standard deviation. Once you have that, you can find the z-scores on the next couple pages here. Okay, so you should be able to complete these. All the way out. They should not take you a lot of time at all. Okay? Now, let's look at this problem here, and I want to change this real quick to 34. Okay, so we're going to change that to 34. This is a little bit of a different problem, but they give you the z-score, so it's kind of like the other problem we just did. Okay, so Ashley's looking at a distribution with a mean of 13 and a standard deviation of 34. Find a value with a z-score of negative 1.69. So they're giving us the z-score is negative 1.69. And we know our formula is our score, which we don't know. We're trying to find that value, minus our mean, which is 13, all over our standard deviation, which is 34. And same thing here. We can just solve this like a normal equation. I'm going to multiply by 34. Okay. When I do that, I get negative 57.46 equals x minus 13. Add 13, add 13. We would have x equals negative 44.96 would be a value to give me negative 1.69. All right, and if we think about this distribution, that makes sense, because if I have here 13 and then I'm subtracting 34, my negative 1 standard deviation will be at negative 21, and my negative 2 standard deviation will be at negative 55. So my value should be something in between those two, and it is. It's negative 44.96. Okay, it's obviously closer to the negative 2 value because it's negative 1.69. Okay, I hope this video helps you guys for z-score problems, and I hope you have a great day.